And the fourth speaker out of 6 is Dr. Robert Amee, who is professor of physics and astronomy at the University of Denver. Let's welcome Dr. Amee.
Good evening, all. This is a fascinating subject for me and always has been. I've done a lot of teaching in my many years at the University of Denver, and I've been pleased to teach a lot of people who have never inkling about the pros and cons of nuclear energy. And I found it appalling when I started looking through high school textbooks. If you're taking a physics course or possibly a chemistry course, you're going to learn what nuclear fission is. But if you learn anything about nuclear technology, it is an accident. And if you go back to middle school, you may be taking a course called physical science. And I've judged something like 35 different textbooks, and I find them appalling, with a few exceptions. So what I'm saying is that the public at large is poorly educated in nuclear technology, and no wonder they have trouble determining the difference between a nuclear weapon on the one hand and nuclear energy on the other, and they're very distinctly different. Okay, so let's see, what am I saying? I don't know if that slide's been shown before, but Goodness perhaps did, but what it tells us is that over the last several years, the opinions that go back to about 1980 or so have diverged in terms of being more favorable towards nuclear power than unfavorable. Those data were collected by the Nuclear Energy Institute, so I won't vouch for their validity exactly, but it does appear to be that 3 times as many people are now more favorably disposed towards nuclear energy than they have been in past years. And I suppose a lot of that because of the growing realization that carbon dioxide is perceived to be a real problem, and the recognition that nuclear energy does not produce CO2 as a byproduct is the reason why the favorability has grown. I wanted to point out that over the years, there's been a lot of developments that are of great interest to the general public. Although there are among some people, there's a pathological fear of radiation. In fact, we live with radiation. The average adult body has 6,000 decays per second going on in the body, or 300,000 decays per minute. And those all come from our foodstuffs. Potassium has been mentioned as one. There's uranium in the soil, radium in the soil, thorium in the soil. So your body is radioactive, although it's very slight. But the important thing is that 1/3 of patients in the United States hospitals receive some kind of treatment involving nuclear medicine. Internationally, about 150 million procedures per year involve ionizing radiation. So ionizing radiation can be viewed as one of our very best friends. There's been a lot happening since the last nuclear power plant was built. And much of that is a result of international efforts, research on materials to improve the quality of materials, to improve the durability of materials, to improve weldings and determination of strength losses. And there's fuel design. We've even created a fuel called MOX, which is a mixture of uranium and plutonium. A lot of that plutonium came from old weapons, and we're turning it into useful energy. And of course, there has always been issues about proliferation. And of course, we found today that with ultracentrifuges, nations can enrich their own uranium beyond where it's needed for power. And they do that without worrying about how much plutonium there is available in the United States. Economics issues, particularly decommission and decontamination of old nuclear facilities. Most people don't realize that if you are using electricity that's coming from a nuclear power plant, you pay a slight millage rate, about 1 mil per kilowatt hour. And that assignment of sort of a use tax has accumulated to $30 billion. Now, 10 billion of it was just spent, perhaps uselessly, on the Yucca Mountain disposal site. But there's still $20 billion available for decommissioning and decontaminating old nuclear plants and disposing of nuclear waste. Generation 4 nuclear, we're currently in Generation 2, and there are a few new plants that are called Generation 3. There's a little paper model out in the foyer, which I've been showing people, and it's a Generation 3 nuclear power reactor. It has more capabilities of avoiding accidents than our current light water reactors. And the viewpoint now is that safety is paramount. The companies that are responsible for building and those companies, utilities, are absolutely aware that one bad operator can wreak havoc with the entire industry. That was exemplified beautifully at Chernobyl. And so on. Well, Yucca Mountain has been in the news a lot because we spent $10 billion trying to demonstrate that this isolated mountain could, in fact, retain nuclear waste indefinitely. And yet there's another one called WIP, Waste Isolation Pilot Project, now called Waste Isolation Pilot Plant. And for people who live in Colorado, this is particularly a wonderful development. It's in a seabed, former seabed, salt bed in the Permian Basin. 250 million years that salt has been inert and immovable. So we're fairly confident that this will be and is being used for high-level waste disposal, permanent disposal. Threw this in for funsies. This is a photograph of the 3 Mile Island control room. And you'll see, interestingly, there's 1, 2, 3, 4, 5, 6 dial telephones. But how many computers? No computers. 1979? No computers. There were some, but they were not being used. And of course, all this stuff is electromechanical and was not laid out in a manner which would minimize risks and minimize mistakes. And just to see what a more modern nuclear power control station looks like, notice all the computers, the displays, all the data available, and you can trace what's going on throughout the plant. There are sensors that are radiation insensitive, so we're getting information flowing into the control room all the time. And there was a great puzzle wondering what was going on in 3 Mile Island. Nobody wanted to go into the control room or into the reactor room to find out, obviously. And so with our modern day systems, this is no longer an issue of that magnitude. Now here's something that has been presented earlier in a little different form, but I just want to point out these are fatalities, combined US and UK fatalities over a period of 22 years relating to these different types of fuel. And these are in terms of terawatt years of electricity, never mind the number, it's the relative sizes that are important. And you can see that nuclear power is the safest way to generate electricity in terms of fatal injuries. These are all workers, and these people, this is not radiation. I want to emphasize that. These are falls from high places, maybe an accident, somebody poured concrete on you, various types of things that may have happened, but none of them has to do with radiation. This is a good example of stacks of nuclear waste waiting to go somewhere. Where? Well, out at Rocky Flats Environmental Technology Site, we had plenty of these barrels waiting to go somewhere, and they certainly weren't going to go to Yucca Mountain because there was still a lot of debate about that, and already they had designed a thing called the Waste Isolation Pilot Plant located in southeastern New Mexico in that salt bed I just described. And that's where all that stuff is gone, and it's safely disposed of permanently. Most of it, if not all of it, has plutonium either in large concentrations or small concentrations.